problems here. When we consume lots of food to stay alive, and we drink beverages, and some of us are addicted to things like caffeine. So I like a cup of coffee in the morning to get going, in addition to doing some math. Oftentimes though, like I overdid it shoveling the other day and I was a little sore. And once in a while when we're sore or hurt, we might take an anti-inflammatory like Advil, Ibuprofen. And when we do things like take caffeine as a stimulant or Advil as a pain reliever or inflammation reducer, they don't last very long in the body. So in a little while, those things dissipate from the body. So I have my cup of coffee, in half an hour, I feel the stimulating effects of the coffee, but a couple hours later, I don't feel it so much anymore. So the body metabolizes these things. So I wanted to go over metabolizing drugs. And often this is called the metabolic half-life of a drug. And the two substances I'm going to look at today are A, caffeine, and caffeine spelled something like that, and B, ibuprofen. And you can look up information about these online, so I'm just going to show you a web page I was looking at earlier. I was looking up ibuprofen. So I just searched for ibuprofen half-life, and there's a bunch of different medical sites I can get to look it up. One that caught my eye over here, where was it? How long does it take ibuprofen to wear off? I thought that was a good one. How long does 800 milligrams of ibuprofen stay in your body? So here, let's check that out. They have a prediction. Ibuprofen is rapidly metabolized and eliminated in the urine. The excretion of ibuprofen is virtually complete in 24 hours after the last dose and has a serum half-life of 1.8 to 2 hours. So let's just test out that 2 hours for 800 milligrams versus 24 hours. So I'm going to do it in a couple of different ways. First, I'm just going to make a table, and then I'm going to come up with a formula for that. So we'll look at ibuprofen first, since I had that screen available there. And we're going to have a starting dose. So start with 800 milligrams. And the claim is that ibuprofen has a half-life, and I'll explain what that means, of 2 hours. And a table is the best way to explain that. So if I make a table for hours gone by, versus the ibuprofen in my system, initially times 0, I take 800 milligrams. And if the half-life is 2 hours, that means 2 hours later, there's half of that left. Half of 800 is 400. And then another 2 hours later, so 4 hours total, there should be half of the 400. There should be 200. So every 2 hour increments, I cut in half the amount of ibuprofen that's measurable in my system. So 6 hours total, another 2 hours, I should be down to 100. 8 hours total, I'm down to 50. And we just keep cutting this in half. And their claim was that 24 hours later, it's not measurable. So I think maybe a spreadsheet would be a way to continue, although 24 is not too much farther away, counting by 2. Spreadsheets are just cool. Let's make a new sheet. And often when I make sheets like this during class, I put them in the description of the YouTube video. I don't know if anyone's noticed that. So let's call this ibuprofen. Call this half-life. And so I'm just going to look at hours versus ibuprofen. And the hours, 0 to 4, that's an easy pattern for the computer. I can just highlight 0 to 4 and then fill it down. And I want to go to 24 hours later and see what happens. Now the ibuprofen part, the computer doesn't know how to continue this pattern, 800, 400, even though I can do it easily in my head. So if I try to copy that and fill it down, the computer's totally going to screw it up. It's going to do weird stuff. So it didn't, that's not what was supposed to happen there. So the only thing I can really do here is say, okay, starting with 800, in the next cell, I just go equals, take the number above and divide by 2. And that formula where I divide by 2, that's what I'm going to fill down, just that right there. And you can see it's going to go 400, 200, 150, 25. And then all of a sudden we get these tiny little measurements, like a tenth of a milligram of ibuprofen, which is not really measurable in the body anymore. So to do that, I started typing 800, and then underneath I just went equals, take that number above, divide by 2. And then only that second cell where the formula is, only that gets filled down. Okay, so I can see that 24 hours later, there's just a tiny portion of a milligram left, and that's not measurable by any test that we have. This is what the claim was. So again, starting at 800 milligrams. If I started with a different amount, like maybe somebody took 1600 milligrams, like twice that, is that a big difference, doubling it? And it turns out still 24 hours later, it's just a fraction of a milligram. And a milligram is a pretty small amount, at least of ibuprofen. Some drugs, it's a lot. Just kind of depends on the drug. But the point is here, every 2 hours, right, we cut the amount we have in half. So that's what the half-life for ibuprofen means. Let's look at caffeine next. Oh, I did spell it right before. Cool. So caffeine. All right, so let's see. Yeah, so here it says for most individuals, it's about 5 hours, but it can range between 1.5 to 9.5. So some people metabolize it different than others, faster than others. So average is about 5-hour half-life. So if we were going to make a caffeine example, so let's do that on a new page. So a typical cup of coffee, just an 8-ounce cup of, regular, the average cheapo coffee you can get in the store, has about 100 milligrams. So let's say we have 100 milligrams of caffeine, which would be an 8-ounce cup of coffee. So most people drink a lot more than that. I can't handle much more than that. So 100 milligrams of caffeine, and I was just told by that website that the half-life of caffeine is around 5 hours for most people. There's a bit of a range there. So for some people, it could be like 3 hours. For other people, it could be 8 or 9 hours that caffeine stays in their system. So I think I'm probably on the upper end. I'm pretty sensitive to caffeine. I can't handle much, and it feels like it lasts a long time for me. So what's this look like table-wise? So if we make a table here of hours versus caffeine, initially we have that 100 milligrams, and now here every 5 hours we cut it in half. So 5 hours later we're down to 50. 10 hours total, another 5 hours we should be down to 25. Another 5 hours, so 15 hours later we'd be half of that, so that'd be 12.5. And then we can just keep cutting it in half every 5 hours. So notice here, every 5 hours I cut it in half, whereas the ibuprofen, it was every 2 hours we cut it in half. So this idea of half-life is pretty important. Now, the thing to note about this, and I'm going to pick on the caffeine one here, to get from this row here to that row here, I had to divide by 2. Now, dividing by 2 is actually the same thing as multiplying by half. So I'm going to look at it that way, because I'm talking about half-life. So to get from 50 to 25, I again multiplied by half. And to get to the 12.5 here, again, I multiplied by half. So to get from 100 to 12.5, I had to multiply by half 1, 2, 3 times in a row. So another way to look at this line right here is to say, starting at 100, multiply by 1/2 3 times in a row. I get this exponential statement. If I took this one more row down 20 hours later, that would be yet another times 1/2. So whatever this number here is, it would have to be, according to this pattern, 100 times 1/2 to the power 4. Right, so half of 12 is going to be 6. Half of a half is a quarter. That should be 6 1/4. Right, let's check by plugging that into the calculator, see what it gives us. Parentheses around the half are important. So starting with 100, multiply by parentheses 1/2, close the parentheses, and then raise it to the power 4. And we should get the 6.25 that I could just kind of look at in the table and get. All right, the next thing I need to do to figure out what the equation is for this is to make a connection between the number of hours that went by and the exponent I get. The number of hours that went by and the exponent I got. And the key there is the 5 hours up here. That 5 hours means I'm looking for groups of 5, right? So 3 groups of 5 is 15. 4 groups of 5 is 20. How do you figure out how many groups of 5 are in a number? Well, you would just take whatever the number of hours is and divide by 5, right? 20 hours divided by 5 gives me that exponent of 4 that I have here. So putting that all together, if somebody said, hey, let the number of hours be called T, then my formula would be to take 100 times parentheses 1/2, and then the power would be the number of hours T over 5. Right? That's what I was figuring out here with the groups of 5. And where 5 is that half-life time. So this would be the formula for half-life for caffeine. Looks a little messier than other formulas we've messed with, but I'll show you a way to clean that up in just a second. And then we're almost done for the day. So let's look back at the ibuprofen one. So in the ibuprofen, the difference on this side is instead of grouping by 5, we're grouping by 2, right? Because we had a 2-hour half-life. But on this side right here, we're always cutting things in half. Cutting things in half, just like before, cutting things in half. So the formula for ibuprofen, let's call it I for ibuprofen, in this case is starting at 800, multiplied by 1/2 a whole bunch of times. How many times? Well, however much time went by, but looking for groups of 2. So I have to look for groups of 2 in order to cut it in half. That's what this says right here. Look for groups of 2 hours. So if somebody tells me for any drug what they started with and what the half-life is, I can just whip out an equation that predicts how much of that drug is going to be in their system however many hours later, which is kind of cool. It turns out that this right here is a lot like our F equals P times 1 plus R to the power T. And so I'm going to show you how these two are related. So let's pick on ibuprofen again. And what I want to compare is the formula that I came up with, which was starting with 800, multiplied by 1/2 to the power T over 2. So 1/2 is because it's half-life, the 2 up here is because the half-life is 2 hours, the 800 is the starting amount. And my claim is I can make this look like the P times 1 plus R to the power T. I just got to figure out what that R is. I actually know what the P is. The P is the 800. So to compare these two, I just kind of get rid of the things I don't really need anymore. I know what P is. So now I just need to consider, okay, how does 1/2 to the power T over 2 relate to 1 plus R to the power T? So the next easy thing to do to kind of get at that relationship is to say, let's just let T equal 1. We could do some fancy algebra here, but it turns out we don't need to. So if I just let T equal 1, then I get 1/2 to the power 1/2 equals 1 plus r to the power 1, which is just 1 plus r. Okay, that doesn't look too bad. What's 1/2 to the power 1/2? Now, on some calculators, to make that calculation, the power might need to go in parentheses too. So I believe on my calculators, I need double parentheses. So, and you could always use decimals in this case, but I'm going to stick with fractions. 1/2 raised to the power 1/2. Oh, and see my parentheses, my 2 jumped out of the power, so I forgot about my parentheses for the power. Parentheses 1/2. And the key is you want to make sure that that 1/2 is in the power. And I'll double check this on my other calculator. So I get 0.7071, let's say, if that's right. Actually, let's just go 3 decimal places, be close enough. So I'm getting that this thing right here is 0.707. All right, let's check the other calculator. So here, I want parentheses 1/2, move over, close the parentheses, and then power button. And it looks like most calculators need another parentheses for the power. You want to make sure that whole fraction is in the power. And I get the same number, 0.707-ish. All right, almost done. So bottom line is, think about it this way. That 1 plus r, that's the base up here. I just found out that whole base is 0.707. So I could say for ibuprofen an alternative equation, and I rounded a little bit, so I'm going to put wavy equal sign, but it's approximate for everybody anyway. It would be just 800 times 0.707 to the power t, because that's what I found this reduces to, and that's like the 1 plus r. Now, since this number right here is less than 1, that means r is a negative, which makes sense because we're losing ibuprofen. So r should be negative here. So how much less than 1 is that? Well, if we look at what is 1 minus 0.707, then we're going to get RR out of that. How much less than 1 is that number? So 1 minus 0.707, and I get about 29%, 29.3%. So this is 0.293 or 29.3%. So what this means is ibuprofen leaves most people's system at about almost 30% per hour is what goes away. So that's just another way of looking at it instead of half-life. But half-life is a common way in medical terminology to talk about how quickly some substance gets metabolized by the body. And the key there was just, we don't really need the starting number to get the rate. And just looking 1 hour later tells us what the rate is. So we keep about 70% of the ibuprofen per hour. We lose about 30% per hour is what that tells us. And we can do a similar thing for the caffeine. But I think that is enough for now. What's the point? The point of all this is we're just getting used to playing around with things that use exponents. And there's a lot of examples in life of that, from a compound interest, a job that has a % raise, car depreciation, and now we've got this new medical stuff in there with like how ibuprofen and caffeine leave the system. And alcohol actually works in a similar way, but we use a different formula for that that's slightly easier. All right, so that's it.